First of all, sorry for my congestion and sinus sounding voice. As I read this, it will be helpful if you have out your periodic table that I've given you in class as we answer and ask and answer some questions as we read. So here we go. 1.5, the modern periodic table. Look at substances A through C in the photos above. They look very different from one another, but they have something important in common. All three are elements, or pure substances. Can you identify which elements they are? For ideas, listen to the Amazing Elements song below. The singer rapidly names all of the known elements while pictures of the elements flash by. Even if the video doesn't help you name the elements pictured above, it will certainly impress you with the need to organize the large number of elements that have been discovered. This is actually pretty entertaining, so take a second and watch this when you get a chance. The first periodic table. In the 1860s, a scientist named Dmitri Mendeleev also saw the need to organize the elements. He created a table in which he arranged all of the elements by increasing atomic mass. That's the number on the bottom. From left to right across each row. When he placed 8 elements in each row and then started again in the next row, each column of the table contained elements with similar properties. He called the columns of elements groups. Mendeleev's table is called a periodic table, and the rows are called periods. That's because the table keeps repeating from row to row, and periodic means repeating. So, in summary, we have horizontal rows are called periods, vertical columns are called groups. Modern periodic table. The periodic table is still used today to organize the elements. You can see a simple version of the modern periodic table in the figure below. The modern table is based on Mendeleev's table, except the modern table arranges the elements by increasing atomic number, that's the number on top, instead of atomic mass. Atomic number is the number of protons in an atom, and this number is unique for each element. The modern table has more elements than Mendeleev's table because many elements have been discovered since Mendeleev's time. In the figure above, each element is represented by its chemical symbol, which consists of 1 or 2 letters. The first letter of the symbol is always written in uppercase, and the second letter, if there is one, is always written in lowercase. For example, the symbol for copper is Cu. It stands for cuprum, which is the Latin word for copper. The number above each symbol in the table is its unique atomic number. Notice how the atomic numbers increase from left to right, and from top to bottom. Question. Find the symbol for copper in the figure above or on your periodic table that you're looking at. What is its atomic number? What does the number represent? Give you a second. The answer, the atomic number of copper is 29. It's right here. The number represents the number of protons in each atom of copper. Copper is the element that makes up the coil of wire in photo A of the opening sequence of photos. Periods of the modern periodic table. Rows of the modern periodic table are called periods, as they are in Mendeleev's table. From left to right across a period, each element has one more proton than the element before it. Some periods in the modern periodic table are longer than others. For example, period 1 contains only 2 elements, hydrogen and helium. In contrast, periods 6 and 7 are so long that many of their elements are placed below the main part of the table. They are the elements starting with lanthanum in period 6 and actinium in period 7. Some of the elements in period 7 have recently been discovered and named. The number of each period represents the number of energy levels that have electrons in them for atoms of each element in that period. In December 2015, the International Union of Pure and Applied Chemistry verified the existence of 4 new elements, 113, 115, 117, and 118, and approved their addition to the periodic table. These elements complete period 7 of the periodic table. Here are the new elements' names and their origins. Element 113 was named, bear with me on this one, nihonium, symbol NH, proposed by Japanese researcher after the Japanese word Nihon, which means Japan. A team of scientists from Russia and the United States named element 115 Moscovium, symbol MC, after Moscow, and element 117 Tennessine, symbol TS after Tennessee. The Russian team that discovered element 118 named it Oganesson, symbol OG, after Yuri Oganesson, a prolific element hunter. Question. Find calcium in the figure above. How many energy levels have electrons in them for atoms of calcium? Slope. So calcium is here. Calcium is in period 4. That's period 1, period 2, period 3, and period 4. So calcium is in period 4. Calcium is a period 4, so it has atoms. So its atoms have electrons in them for the first 4 energy levels. So if you were drawing a model of calcium, it would have excuse me, 4 rings around it. It would have 1 ring, 2 rings, 3 rings, 4 rings. All right. Groups of the modern periodic table. Columns of the modern periodic table are called groups, as they are in Mendeleev's table. However, the modern table has many more groups, 18, compared with just 8 in Mendeleev's table. Elements in the same group have similar properties. For example, all elements in group 18 are colorless, odorless, such as neon. Neon is the element inside the light in opening photo C. In contrast, all elements in group 1 are very reactive solids. They react explosively with water, as you can see in the video. So you're going to want to watch this video. In fact, we may watch this in class. This is the first group of the periodic tables moving down as it shows its reactivity with water. And it's pretty impressive and violent. This is a picture of the alkali metal sodium reacting with water. It's very explosive. Classes of elements. All elements can be classified in one of 3 classes: metals, metalloids, or nonmetals. Elements in each class share certain basic properties. For example, elements in the metals class can conduct electricity, whereas elements in the nonmetals class generally cannot. Elements in the metalloid class fall in between the metals and nonmetals in their properties. An example of a metalloid is arsenic. Arsenic is the element in opening photo B. In the periodic table above, elements are color-coded to show their class. As you move from left to right across the period of the table, each period of the table, the elements change from metals to metalloids to nonmetals. Question. To which class of elements does copper belong? Metal, metalloid, or nonmetal? Identify 3 other elements in this class. Consult your periodic table to do that. The answer: in the periodic table, or the figure above, the cell for copper is colored blue. This means that copper belongs to the metals class. Other elements in the metal class include iron, sodium, and gold. It is apparent from the table that the majority of elements are metals. So, in summary, the modern periodic table is used to organize all the known elements. Elements are arranged in the table by increasing atomic number. In the modern periodic table, each element is represented by its chemical symbol. The number above each symbol is its atomic number. Atomic numbers increase from left to right and from top to bottom in the table. Rows of the periodic table are called periods. From left to right across the period, each element has 1 more proton than the element before it. Columns of the periodic table are called groups. Elements in the same group have similar properties. All elements can be classified in one of 3 classes: metals, metalloids, or nonmetals. Elements in each class share certain basic properties. From left to right across each period of the periodic table, elements change from metals to metalloids to nonmetals. That wraps up 1.5.